One topic that students typically struggle with is solving three-variable systems of equations. And the biggest issue with this is usually keeping track of your numbers, small mistakes. So I have a way of numbering that I think helps keep everything organized. So we're going to look at solving a three-variable system, and we're going to number all of the equations and turn this three-variable system into a two-variable system. So the first thing I do is number my three equations. We've got equation 1, equation 2, equation 3, and we want to eliminate one of the variables. It doesn't matter which one you eliminate as long as you eliminate the same one for your first two steps. So we could get rid of x. We could take equation 1 and combine it with equation 3, but we would have to get these coefficients opposite. We could get rid of y, and if we look here, we've already got positive and negative y. Those are going to cancel out easily. And then we've got a negative 2y, so that'll combine with equation 1. So y looks like the easiest to get rid of. We could do z also. We could do negative 3z and positive z and turn this equation 3 into a positive 3. And we could also do equation 2 and 3, but we would have to change this equation to negative 2. My rule of thumb when dealing with three-variable systems is do as little work as you have to in order to eliminate your variable. So if we only have to multiply one of the equations, go with that. If you have to multiply multiple equations, that complicates it a little bit. So in this example, we're going to start by getting rid of y with equations 1 and 2. So we're going to take 2x plus y minus 3z equals 1, and we're going to eliminate y with equation 2. So now, once you get these variables, these y variables here, to have opposite coefficients, we can combine the rest. So we're going to add and combine our like terms. The y's cancel. This gives us negative z equals 14. So we end up with equation 4 as 5x minus z equals 14. So now I've created a two-variable equation, and I label that as equation 4. Since I used equation 1 and 2, I have to use equation 3 now with one of my other two. So I still want to get rid of y. I need to eliminate y this second time. So I'm going to take equation 3 with negative 2y, and I'm going to combine it with equation 1. So we're going to go equation 1 and equation 3. But now, in order to make these opposite, I'm going to have to multiply equation 1 by 2. So I want to multiply every term in here by 2 in order to cancel out this y value. So that's going to give me 4x plus 2y minus 6z equals 2, and 1x minus 2y plus z equals 8. So now I'm going to combine here. I have 5x minus 5z, and again the y's cancel out. We want to make sure that we cancel out the same variable, equals 10. And this will become equation 5. So the key to doing all of this and the numbering and organizing is to keep it as clean and organized as possible so we can go back and look at our mistakes, because you're almost guaranteed to mix up a sign or multiply or add something incorrectly, and it's usually a simple mistake. But if your handwriting is sloppy or you don't have it organized, it's very hard to figure out where you made that mistake. So now I'm going to combine equation 4 and 5. And all I've done now is taken my 3-variable system and I've turned it into a 2-variable system. I've got 5x and 5x. I've got negative z and negative 5z. I can eliminate my x's by multiplying either equation 4 or 5 by a negative 1. So I'm going to multiply equation 4 by negative 1. That's going to give me negative 5x plus z equals negative 14. And then I bring equation 5. 5x minus 5z equals 10. Now I combine these and I can solve for my remaining variable. That gives me negative 4z equals negative 4. We divide by negative 4, and z equals negative 1. Or I'm sorry, positive 1. Watch your signs there. There's a easy place to make a mistake. So now that we have z, I can take this I can take my z and I can plug it in to either one of these. So I'm going to plug it into equation 4. So that's going to give me 5x minus z equals 14. And I'm going to plug that 1 in there. So I substitute z back into either equation 4 or 5. That gives me 5x minus 1 equals 14. 5x equals 15. We're going to add that 1 to both sides. Divide by 5. And x equals 3. So now I've got z is 1 and x is 3. I can take those two and plug them back into any of these. I'm going to use equation 1, the original equation 1, because I have y by itself. So I can take x and z, and I can go 2 times x plus y minus 3 times z equals 1. And now I'm going to plug in my 1 and my 3 in for x and z. So that's going to give me 6 plus y minus 3 equals 1. We can combine these terms here. So that's going to become y plus 3 equals 1. So then I subtract my 3. Y equals negative 2. And so now I've got my 3 variables. I write that as an ordered triple. So my answer is going to be 3, negative 2, and 1. And so with these, you can check them. We can type them in here. 3 times 2 is 6. 6 minus 2 is 4. 4 minus 3 is 1. So that checks out. 3 times 3 is 9. Minus negative 2 is 9 plus 2 is 11. Plus 2 gives you 13. And then 3 minus 2 times negative 2, so that's 3 plus 4 is 7, plus 1 is 8. So all those check out, and we have our solution. So the summary for this one is stay organized, use your best handwriting, so you can go back and read. And the final thing is always eliminate the same variable when creating equation 4 and 5. I hope you enjoyed that. I hope that helps. If that helps you out, subscribe to my channel and stay tuned for more videos.